Welcome to this video. So in this video I'm going to be focusing on a very important feature of C++ called templates. Templates are the foundation of generic programming in C++ and they're a very powerful uh, feature. So let's quickly go over this. So why do we need a template? So for instance, let's say you have written out a function which has performs a certain set of activities. So like let's even take a look at this. So you've got just two statements here, which is not really doing much. This is outputting some parameters to the console. So let's assume I want to let me say I want to have a function which takes a type integer, and then it takes a type float. Okay, and then then I then decide that I also need another function which probably takes in a type string and a type character. Okay, so this needs to be std string. So as you can see, I have now got to define two separate functions if I want to support different types. So the first function supports a certain set of types, integer and float, and the argument types are different here for the second function. Now instead of having to write, and maybe I might want to write a third function as well, which takes something else as input. So maybe I might want to pass float as the first argument, and maybe a float as the second argument. So as you can see, this is going to become pretty messy as we keep adding support for different types. So this is not necessary at all. So instead of that, all that we need to do is just define a template. So a template is nothing but a blueprint, and by that I mean you got like a plan in place, and the compiler knows that this is just only a template. It's not really an actual function. And what happens? So the template is defined in this manner. So t here and q here are actually the types, and we have shown these parameters in the function template to be of type t and of type q. So the instantiation of this parameter happens here. So I just call my function with the actual arguments. Now when the compiler encounters this at compile time, it's able to bind these arguments to these uh, function template parameters, and it's able to deduce the type. So like the compiler is able to figure out that this is a string and this is probably an unsigned integer, and it binds these types, these types that it deduces, it binds these types to the function templates parameters. So that's how it's able to generate the code, and then it's also able to allocate memory because it's able to deduce what type it is based on the actual arguments that you're passing. So all that I need to do now is, like, let's say I want to call it with a different type. So all that I need to do is just call it. That's all with the actual arguments, and maybe I want to pass a float here, and let's say I want to do just the reverse here. So let's say I want to do 100.345 whatever, and then here I pass maybe a string, let's say C++. So as you can see, no errors have been flagged by the IDE. So let's go ahead and compile this and see what let's run this piece of code and let's see what happens. Awesome. So as you can see, so we have param1, C++ course, and 2022. So that's our first function call, and the next one is param1 is 2002 that we have seen here, and then the second param is 45.5. So and the third one is 100 and C++. So at every call to this function, what happens is the compiler instantiates this template. It uses this template and instantiates the function that is required based on the type of arguments. So as you can see, we really don't have to overload the function. All that we need to do is define this function template just once, right, and supply these uh, types to the parameters of the function. So the other thing I just wanted to bring out is type name can also be can be replaced using the keyword class, but I prefer using type name because that sort of signifies that what follows is actually a type. So T is a type, and using the keyword type name is probably what I would recommend. So yes, that's it for function templates. So I would invite you to probably explore this a bit more, and I'll see you in the next video.